feelings, our emotional responses.
Precisely. And this leads to more contemporary perspectives, which the paper highlights, seeing morality as truly multidimensional. It's an integration of both rational and emotional aspects, tied into our sense of moral identity, character, even our personality. This more integrated view really requires cross-referencing insights from philosophy, ethics, and neuroscience to get the full picture.
Which brings us to where things get really fascinating, especially if you're thinking about building machines. How does understanding the physical basis of morality in the brain inform this huge challenge?
Well, neuroscience has spent decades trying to pinpoint the origins of our moral sense within the physical structures of the brain. Specific regions, networks, neurochemicals. The classic, though tragic, case of Phineas Gage back in the 1840s is a stark early example.
Oh, yeah, the railroad worker.
That's the one. Damage to his frontal lobe didn't just alter his personality, it fundamentally impaired his social and moral judgment, while leaving many of his other cognitive abilities pretty much intact. It was a powerful early clue that our moral compass isn't just abstract thought, it's deeply embedded in our brain's architecture.
Wow. So it's not just a philosophical concept. It has a physical address, so to speak, in our heads.
Exactly. And modern neuroscience delves into the role of specific chemicals, too, like oxytocin. It's strongly linked to trust, maternal bonding, and interestingly, dampening aggression in social contexts.
Okay.
This suggests a biological basis for the social connection and care that are so interwoven with morality, kind of like Gilligan highlighted.
And brain imaging studies really show this complexity in action, don't they? Different brain areas seem to light up depending on the kind of moral situation you're presented with.
They absolutely do. The dual process model, championed by researchers like Joshua Green and Jonathan Haidt, is a great illustration here. They looked at dilemmas involving direct personal harm, like the Indian bridge variant of the trolley problem, where you'd have to physically push someone.
Yeah, that one feels very different.
It does. Versus more impersonal, calculating dilemmas like just flipping a switch in the classic trolley problem. What they found is pretty striking. The personal, emotionally charged dilemmas tend to activate areas involved in understanding other people's thoughts and feelings, and empathy regions like the superior temporal sulcus, posterior cingulate gyrus, medial frontal gyrus.
So the parts of your brain that help you connect with and understand other people's experience make sense.
Precisely. But when faced with a more cold, rational calculation, like the standard trolley problem switch scenario, the prefrontal cortex, our primary reasoning and executive function area, shows more activity.
This really solidifies the idea that human moral judgment isn't purely one thing or the other. It's a dynamic interaction, right?
It absolutely is. Green and Haidt argued for this blend of thoughtful reasoning and more automatic emotion or emotional intuition. And thinkers like Patricia Churchland take a very naturalistic view, proposing that fundamental aspects of human sociality, cooperation, and care are actually evolutionary products shaped by the mammalian brain, linked to neurochemicals like oxytocin and vasopressin.
So it's this incredibly intricate system, integrating cognition, emotion, learned principles, maybe even evolutionary drives, all orchestrated across diverse brain regions like the ventromedial prefrontal cortex, anterior cingulate cortex, and the amygdala.
Yeah, areas involved in processing things like guilt, empathy, regulating our responses in social situations.
Right, it all sounds so interconnected.
It is. And integrative models like the dual process approach, or even broader three-brain theories, though some are more conceptual, they underscore how these complex neural networks involved in both cold judgment and hot emotion are deeply intertwined in shaping our moral responses. Understanding this profoundly integrated, complex, and often, frankly, messy nature of human morality is an absolutely essential prerequisite before we can even begin to think about replicating it in machines.
Which leads us directly to the monumental challenge. How do we possibly take our understanding of this biological, emotional, relational human brain and apply it to building artificial intelligence? We know AI research is inspired by neuroscience, deep learning networks, reinforcement learning, mimicking reward systems.
That inspiration is definitely valuable, but as the paper points out, citing distinctions highlighted by thinkers like Porter, there are fundamental architectural and functional differences between biological brains and digital computers that pose really significant hurdles for directly modeling human morality.
Okay, lay out some of those key differences for us. What makes the brain not a typical computer?
Well, fundamentally, the brain isn't really a digital computer in the way we usually think of one. It doesn't have a single central